Right, welcome to another maths video. Okay. This time we're going to be doing a question that I have been quite reluctant to do, but we'll do it anyway. It is the rate of change kinematicsy one, very physicsy, I'd say. I agree with myself in saying that this is quite physicsy. Hence why I do not want to do it. Oh, this tastes really good. Hold on. What's this? Okay. Anyway, let's get started. So, the question we're dealing with is question 1D. It has 3 parts, I, and I. It was an extra I at the end, sorry. And this is our introduction. A skier reaches the last section of his run. His speed when he reaches this section is 6 meters per second, but he immediately accelerates at a constant rate of 1.5 meters per second squared for a further 5 seconds. Okay, so I'm going to do part 1 first. As you can see, I've used a highlighter. Unfortunately, I lost the photo I took of George's notes, but I vaguely remember them, so I'm pretty sure I'll be able to regurgitate them enough for me to do this question. But right now, I've done this question on my own, so we'll see how wrong I am tonight. Okay, so first part. What is the velocity of the skier 5 seconds after passing the start of the last section? Right, so first of all, we're given 5 seconds, and we're given 1.5 meters per second squared. Now what we can do is that we can do 5 times 1.5 meters per second squared equals 7.5 meters per second. So that's the speed that, or the velocity that the skier is going 5 seconds after passing the start of the last section. And then after that, we can add the start speed. So we'll do that. Add start speed. And this will equal 13.5 meters per second, because the start speed is 6 meters per second. So that means it'll be 13.5 meters per second. Cool, and then that's all I would do for this question. You're not going to get anything higher. I wouldn't think you would anyway. Even if you did it a fancy way. The other way you can do it is just pointless in teaching you. This way is easiest because it's an achieved question, and I'm not going to elaborate on an achieved question. Cool. So the second question: how far past the start of the last section will he have travelled in this time? Ooh. 5 seconds. Okay, so we know that. So hopefully you guys understand rate of change. If you don't, you can go to pages 100 and 112 in the EAS workbook, and they should comprehensively describe how rate of change works and what each function means. So we've got f of t, and that's gonna equal s prime of t, which equals 1.5 t plus 6. Yep. And s, if we're going to make, s of t, so s of t is basically displacement, v of t is velocity, and the rate of change of displacement is velocity, and the rate of change of velocity is acceleration, but we're just going to get to that now. So S of t equals 0.75 t squared plus 6t plus 0. Yeah, that'll be right. And then we're going to make S of 0 equals 0. And that would mean that, well, now we're doing a lot of anti-differentiation here, I suppose. Not differentiation and stuff like that. We're doing a lot of calculus-y stuff. So that would mean that 0 equals 0.75 0 squared of 0 squared plus 6, 0 plus 0, and that would mean that 0, in fact, seriously, oh no, that makes sense. Okay, so S of t, now displacement equals 0.75 t squared plus 6t, and that would mean S of 5 equals 0.755 squared plus 6 of lots of 5. I'm not doing that in my head. Fuck that. Okay. Sorry for the swearing. Oh. No, I mean 0.75 here, not 55. Sorry. Okay, that would equal 48.75, and that means we've found our displacement function, which is what they asked for, because they wanted to know how past the last section we have travelled in this time, meters. Here we go, so that's how far we've gotten so far. I've done question part 1 and part 2. Okay, so now for part 3. If after 5 seconds the skier then adjusts his legs to brake and decelerates at a constant rate of 2 meters per second squared, how far from the start of this last section will he stop? Give me a second. So the current question we're reading is this one here. If after 5 seconds the skier then adjusts okay, so, right, our function for acceleration equals -2, because, yeah, I know we're not accelerating, we're decelerating, but still, it's that, we'll use this. Anyway, it says -2, so you should know this, equals v prime of t. Cool. I think that's cool. And we know that v of t would equal -2t plus c, and we would know that 13.5, because we found what this is, would equal -2. We're just doing a lot of substitution here now, sorry. 0 plus c. Oh, good. Therefore, c equals 13.5. Yep, makes sense. Good. Right, so then we've got v of t, which equals s prime of t displacement. So we've got rate of change of we've got velocity. The velocity function equals the displacement, primary displacement function of t, which equals negative 2t plus 13.5. Oh, yep. So when the v of t equals 0, the sphere won't be moving. So when you need to know, I need to write this down. V of t equals 0, the sphere won't be moving. Cool. Yeah, that makes sense. I think I agree with myself there. So this is how far we've gotten so far. So that means all we have to do now is, well, we know that this equals 0 when he's not moving. So, sorry, this is 0 because we've made up that this equals when we should know that when the velocity function equals 0, then the sphere won't be moving. Doesn't make sense of, yeah. So anyway, so that would equal negative 2t plus 13.5. So what would that mean? That will mean Dylan will be using the solver. Really? Whoa! No way! Oh look, I could probably do it by being a winner and using my head, but I don't want to. Okay, so that means that therefore t equals 6.75 using solver. Well, I don't think the marking team's going to say, oh no, they have to work this out by hand. Oh, anyway, I haven't. There we go. Oh, so good. I just realised. Oh, yes. Okay, so we're going to have to do some nice maths. So we're going to have to substitute this back in. We're going to substitute it into s of t. So we will know that s of t equals negative t squared plus 13.5 t. Okay, so let's do that. So s of t equals negative t squared plus 13.5 t. Substitute in our value of value of t. S of 6.75 equals 6.75 squared negative 6.75 squared. That's meant to be a t, not a 6. Looks too much like a 6. Okay. And that will mean that, put that in brackets just to be safe. And then we'll have equals, no, what am I doing? It's too messy. Equals 6.75 squared plus 13, negative 6.75 squared plus 13.5, lots of 6.75, and that would equal Sorry, this is taking... Fucking lovely. Equals 4... I don't know if I'm doing this right. Negative 45.5625 plus... yeah. 91.125 which equals... Fuck this. This is so good. Love this maths. Okay, cool. And that... Oh, good. I think we did it right. That would equal 45.5625. Yeah, it's positive. I don't know. It seems really long. Maybe. Yep, so this is how far we've gotten so far. Oh, maybe I can zoom out. Yep. Okay, cool. Oh, then we'll have that. Oh, well, we can just do... Well, we know that 48.75 is our acceleration distance. Add that to 45. 0.5625, and that would equal... stop fucking... Bitch, fucking thing. 94.3125 meters. So this one here is our deceleration distance. This is our acceleration distance. So deceleration. Yep. So that's our final answer. Our acceleration distance, because it's asked for the how far from the start of the last section where we stop, and we'd need the acceleration distance and deceleration distance, and that will equal 94.3125 meters. What did I think? That question's bullshit. I hated every second of that. Oh, sorry, I'm using mean language. That question is very not cool, and this question actually offends me, because it's like I have to rely on my calculator so much of the time. Usually I can do quick maths, but then these are stupid numbers. Not cool. I hope that's helpful. I hope you understand how I did it. So, if you want further learning into how to do the, those lovely rate of change kinematics questions, you should look at pages 100 and 112. Kinematics 1, kinematics 2. They're quite comprehensive. Probably more comprehensive than me. Well, yeah. So, basically, we really will be told from that is that the rate of change of displacement is velocity, the rate of change of velocity is acceleration, then you'll be told the opposite. The antiderivative of velocity is displacement, the antiderivative of acceleration is velocity, and so what they generally that displacement is represented by S of t, acceleration is represented by A of t, the S bracket t bracket A bracket t parentheses, I don't care, and then velocities, and then represented V of t. But they'll tell you there's more information there, I think. Okay, thank you for that, for watching this. If you did, well done. If you understand how to do the question. If I listened to myself, then I wouldn't understand how to do that question at all. Bye.